Welcome to Humans of Reliability. My name is Sylvain Kalash, head of the Rootly AI Labs and your host for today. In this episode, we welcome Julien Simon, VP and Chief Evangelist at RC, an open intelligence lab. Let's dive in. Julien, from a reliability point of view, for people who are using hosted LLM, what are the main challenges that they are facing?
It's never different this time. So if you're working, and you're going to hear me say that a lot, if you're working with hosted APIs, like OpenAI or Anthropic or Amazon Bedrock, any of those, at the end of the day, you're still working with a cloud-based API. So all the usual concerns will apply, and I guess more concerns will apply. But generally, you need to worry about, of course, uptime, and maybe you get an SLA, maybe you don't. You need to worry about latency, so how long it takes to actually run one inference query. Throughput, how many parallel queries can you run? How quickly do you get throttled? Do you have explicit throttling limits, or do you have soft limits? Do you have hard limits? Are they public? Are they real? Have you tested them? Load testing and all that good stuff. And of course, I would add security. And that's not really part of reliability, but it needs to be in the picture. How much can you trust that API, because you're going to be sending it all your good data, your confidential data, customer data with PII probably, and so on. Just generally treating those as, I would say, a vanilla API is a good place to start. And don't let, the AI magic blind you. It is an API. It's running in the cloud, and it can break and fail and slow down in every possible way. That's where you should start. Figure that out, do some testing, check out SLAs. Hopefully you have one. If not, what's your backup strategy if that API fails, et cetera, et cetera.
Right. And many people complain about, hey, like, let's say I'm gonna query like the same model, but from different providers, and I'm getting like drastically different responses and capabilities. Like, why is that?
That's a really good question. It's a thing. It's real. and you could think, well, if let's take a basic example. Let's say you're calling Llama 3 8 billion or 70 billion or any one of them, okay? And you've tested the model on you downloaded the model from Hugging Face, probably. You tested it, you liked it, and then because you don't want to run your own infrastructure, and maybe we'll get there later, you just want to call the hosted version. And there are lots of great providers out there, Together AI and many, right? Like everybody has a Llama hosted variant. The thing is, it might start as the Llama model from Hugging Face, but it's fair to say they tweak that, right? So first of all, even if they use the same model artifact that they downloaded from Hugging Face, the deployment scenarios, the deployment parameters will be different, right? Somebody will use VLLM, somebody will use SGLang, somebody will use Llama CPP. And all of those have a zillion parameters that can influence text generation and so on. How they do batching is very important as well. Are they, chances are they will do a lot of batching to optimize throughput, et cetera, et cetera. And again, this can lead to fairly different generations. But then what a lot of them do is, because they're running at scale and they have to, pull all the ML engineering tricks, they actually use modified versions of those servers. So they have their own version of VLLM. They have their own tweak for, to squeeze some more performance out of it, because at the end of the day, the more traffic they can serve with the same amount of infrastructure, the more margin they make. And that's totally legit, right? They're doing the right thing. They're optimizing the business, and that's totally okay. But that can introduce more and more differences. And of course, a lot of them will, modify the model. The model will be compiled. The model will be quantized. And that introduces another level of variability, let's say, right? Because all those tools have different parameters, and 8-bit quantization is just a general is a general thing, but you can apply it with so many different algos, and each one of those algos has different parameters. And if you use model compilation, etc., again, it's another bag of tricks. So a lot of those differences will show up. And they may use different versions of those different tools, different PyTorch version, custom PyTorch version, different CUDA drivers, different blah blah blah. It is a complicated stack, and I think generally. Don't get me wrong. I mean, all of them are trying to do the right thing, right? They're trying to give you the best performance, the best throughput, hopefully the best price, and they're trying to make money in the process. So it all starts, it comes from the right place. Good intents, but things end up being a little bit different. And so it means if you want to switch from one provider to the next, if you believe a little bit naively that well, let's use the same model and it will behave the same, let's send the same prompt, we'll get the same result, more or less, your mileage may vary. And as always, please test, and test some more.
Which is crazy because LLM are already undeterministic. So if you add on top of this, all of what you just mentioned,
they are trained to be creative, right? I keep telling everybody, if that's not what you want, then maybe you don't need to use GenAI, right?
Right.
If you want very, very deterministic, very stable answers, then GenAI is probably not what you want. You can still use the transformer models, but you can use the older transformer models and get more control. But you can't blame them for being variable and creative. It's how we train them.
Yeah, no, for sure. There are other, if I may say, flavors of AI, machine learning, deep learning, etc.
That
have been around for a while. It is not. Do you think? And that's not something we plan on discussing, but. We've like when I was listening to you, I was like, hey, this is nothing new. Like even with deterministic, if I may say, traditional software, we were running into this situation where, hey, I have the same code base, right? It runs on my machine, doesn't work in production, right? Which is why we came up with containers.
Yes.
Do you think
these are complex stacks and very complex stacks?
Is there something similar coming for LLM? Do you think? In some shape or form, or some concept that could be similar to what we've done with containerization?
I think, like I said, it's never different this time. It's just more complex. It's more fluid. There are more moving parts. And at the end of the day, it is still software engineering, right? I mean, it's still, people want to say ML ops. Great. I mean, that probably looks good on your resume. And of course, optimizing GPU servers and GPU clusters is a bit different from optimizing CPU-based Docker and Kubernetes clusters. So there's certainly some specific skills. But at the end of the day, it's still DevOps. It's how do you build the runtime environment that works best for your company and your customers. And of course, you need to define what best means, as always. Right now, there are so many tools. There's a lot of open source, and that's awesome. But it's moving very, very fast, and I'm sure it will keep moving fast for a long time because the models keep changing too, right? So every time you have new model architecture coming out, every time you have a new amazing machine learning engineering technique coming out, it's going to be implemented in those tools, and there are going to be tiny and not so tiny differences. And again, you have to live with that. Do we ever get to a point where we have a super standard stack? Honestly, I don't know. Is there such a thing as an AI equivalent of the LAMP stack, from so many years ago, or the Kubernetes Helm Prometheus stack? bringing standardization at the AI level. Honestly, I don't know. I think it's all those tools I mentioned, right? I mean, they're used today, but I think one of the things I keep repeating as well is if you use the same model and if you use the same stack and if you use the same GPUs as everyone else, where's your competitive advantage? We need flexibility, and we're far, far, far from full, commoditization of AI models. Maybe, what's the S3 for equivalent for AI? I don't know. We'll find out in 10 years. Do we converge to 2 or 3 models that are, just so great that we don't need anything anymore, just like S3? Even though they keep adding stuff to S3, right? But I would think, everybody probably uses 89 or 95% of what everybody uses are still the S3 features from 10 years ago. All the newer stuff is just, I might not even know about it. So I think we're still far from that in AI. And we have to live with the fact that it is going to be a very fluid stack. And that's why you need the right people and the right skills to keep everything on the road.
I think the fluidity, actually, I have a question about fluidity. Do you think that reliability team should try to reduce and limit the number of moving part and unpredictable part of their stack? Or do you think they should embrace this chaos and use kind of new principle and new tools, to live with what you just described, which is this constant change?
Yeah. If you're in startup land and you're looking for product market fit, and you can break everything every week and rebuild it, and honestly no one really cares because you don't really have customers right now. Yeah, go and find whatever your customers are ready to pay for, and then be a little more reasonable. A lot of the customers these days are really looking at production. We're way beyond POCs, we're way beyond experimentation, etc., etc. So, and they have a lot of ongoing projects. So you know better than I do. Then the closer you get to production, the more robust your solution should be, the more long-lived it should be. I mean, no one deploys stuff that is going to live for a week and then be torn apart, right? I mean, if that's the case, then it wasn't a production deployment. So I think once, it's okay to experiment a lot. It's okay to try a lot of new things and all the bleeding edge stuff. But as you get closer to production, you need to, as always, you need to reconsider every part of the stack and say, can I live with this thing for 6 months? Can I live with this thing for 2 years? Right? I mean, some companies will deploy solutions that are supposed to go, on and on and on and scale for 2, 3, 4, 5 years, because that's how they work. And you could say, no, that's unrealistic. AI in 5 years, we don't even know. But that's how those companies work. The more traditional company, they're process driven. They did a cost analysis. They did an ROI analysis. And if they're launching, customer support solution, I mean, that thing needs to run 24/7 at scale for the foreseeable future. Maybe that's 2 years. Maybe 2 years down the line, they'll revisit it. So if you keep betting on open source projects that look sexy, right now, but will become unmaintained or messy or crazy over time, that's not the right bet. So I think, I think one way I've always liked to work is just, like a wave philosophy. Okay, right now I'm building something, and that wave is going to, keep moving for 6 months until I get to production. So will I change all my stack 2 weeks before production? No. That's it. That wave, that really is going out. Okay, maybe 6 months later, we get a shot at updating it, and that's fine. We can maybe upgrade the VLLM version, or we can get rid of VLLM and try something else. And, while we're pushing this thing to production, there's a new wave that starts to form for the next project, and that's a different one. And maybe, you can resync on the latest tools for this one and then keep following. But, I've always been, there's an urgent patch, go and take it. There's a security patch, of course, go and take it. If there's a major release and you're, 2 weeks from production, come on. You just don't do it. You stick with what you validated, and you don't put everything at risk. And it's an iterative process. Again, AI is software. is ops, DevOps. So get something out there, don't hit the pause button just to say, oh, wait. Llama 3.3 came out, Llama 3.4 came out. Yeah. If you think it's going to behave the same, you're going to be disappointed. So get what you have. You have a pipeline of projects, and each project has a pipeline of releases. Get your projects and your releases out. Get some business value out of them. Get some user feedback. Get some metrics. Do all the good ops work that you know how to do, and then feed that back into the roadmap for the next release. If you keep chasing, like every single new version, every single new library that you read about on wherever, I don't want to give names, I'm going to make more friends, it's a house of cards. I don't want to name projects. We all know who they are, and they every commit is potentially a breaking change, and you can't just build anything solid on that.
So speaking of open source, what do you think? There is this argument about closed source model versus open source models. I think we've seen open source model now like performing like very, very well. Like, what are your thoughts about open source when it comes to LLMs?
Well, I worked at Hugging Face for 3 years, and now RC is still sharing all the models on the Hugging Face with Apache 2 licenses. So, that's where I stand. I think, when ChatGPT came out, it was amazing. I think it educated everybody on what GenAI could do, what chatbots could do, generally conversational apps could do in enterprise environments. And that's very positive. They did all the marketing for us. But then, it's once you're past the initial excitement, once you're past the initial POCs, as you start moving again, to production and scaling, you realize that performance is not that amazing. Generation speed, the so-called tokens per second that you get from those large models is not that amazing, honestly. Some of them are faster, but if you end up generating a ton of code, for example, generation speed matters a lot, right? If you can generate your app in or whatever you're after in 30 seconds instead of 5 minutes, it is a thing. So speed and throughput are important. Again, privacy and security are really important. In the US, people don't care because like nobody has an issue with using US-based APIs. But I travel a fair bit, and if I go to, let's say, Singapore, or if I go to UAE, just a couple of examples. Well, there is a concern that why should I send all my good data and my customer data and my confidential data, potentially my government data, to a foreign country, right? And it goes both ways. Let's just reverse the situation, right? You can understand where they come from. So there's that, right? And generally, and we've seen that a lot with enterprise use cases. I keep describing those hosted models as a mile wide and an inch deep, or a kilometer wide and a centimeter deep, if I want to use the metric system for European friends. And in a lot of cases for enterprise, you need the exact opposite. You have a very narrow use case. You want to solve a very specific, set of tasks, or very specific organization and a very well, defined group of customers. And the corpus of knowledge that is required is very, very narrow, but it needs to be very deep. Okay. So you don't want to do astronomy, you don't want to do cooking recipes, you don't want to do poetry, you don't want to do your homework. You want, deep financial services knowledge on whatever, or deep healthcare knowledge on whatever. And so a lot of customers have reported that the large models were lacking because, of course, they only know what they've been trained on. It's a good thing they haven't been trained on your private confidential company data. So those three things, cost and privacy, domain knowledge, and performance, or four things actually, are what drives a lot of organizations to considering open source models. Generally, they're happier understanding what they're working with. If you ask me what is Claude 4.5, if you ask me what is GPT-5, I don't know. Only Anthropic and OpenAI know what these things are. Is it one model? Is it many models? Is it more than models? Is it, models plus apps? Probably, and in terms of, again, understanding what you're building with and compliance, etc., it just makes more sense to have for more control and self-host a model for security, and have, if you want to and if you need to, have the option to train the model further, specialize the model further, etc., etc. And those are the really the things that we keep seeing. But it's not black and or white. There's a world where it's a big world and there are so many different use cases, and within the same company, hosted models could work just fine for the less critical stuff, and maybe it makes more sense to have a tailored so-called small language model or open weights model for your particular use case. Just to use the right tool for the job, I guess.
Yeah. Maybe actually you can share a little bit for those listeners who don't know about small model, open weight. Can you give a gist of what those are?
Sure. So those models are typically, again, what you will find on a Hugging Face. It's well over 2 million models now. So those models are designed and trained by the open source community at large. And yes, it does involve, very large tech companies like Meta or Google or Microsoft or, OpenAI. OpenAI actually started as an open weight model company, and then they became what they became. And then they released more open source models. And anyway. So it's complicated. It's not just a bunch of geeks using company servers to train models. It's actually, a lot of those big tech companies, NVIDIA too, right, have a strategy to build and share open weights models. But then, and then those are still, expensive efforts. Okay, we know because we're doing the same. We're also a model builder. So we're also, training net new models from scratch, et cetera, et cetera. So that's still an expensive proposition. But the value comes from sharing those models and having the rest of the community, hundreds of thousands of people out there taking those base models and fine-tuning them, specializing them over a zillion data sets. Right? Hugging Face has models and data sets. So, you could say, hey, I'm going to take the latest RC model, and maybe I have let's say a legal use case where I want a model that can understand, contracts and NDAs and U.S. law, whatever. And chances are you will find those data sets on a Hugging Face, or maybe you have a corpus of company data that also works there. And so you can take that base model and you can train the model further on that company data, and that becomes your model, right? That becomes a new model in a way. You can share it or you can keep it for yourself. But as it turns out, a lot of folks are sharing those models, and that's how you get to 2 million models. The new base models that are built by the AI labs. And then you get the community just, tuning them, specializing them, quantizing them, optimizing them. And this creates, a ton of options for customers to go and, maybe look at those models, maybe find something off the shelf that works just right for them. And that solves all those LLM problems. And if not, they can just take the base model and build a good data set and specialize it.
Would you say that, obviously, as you said, open source model comes with the advantage that you can self-host it, but yet I think a lot of companies decide to use open source model, but hosted ones. What is that?
At the end of the day, do you want to run your infrastructure? Yes or no? Does it make sense to run it? Yes or no? If you're running at scale, you could say, well, maybe I can justify the cost of those on-prem servers. Maybe I can justify the cost of those AWS or Google instances, and I'm in control and I can run them 24/7 and that's fine. And I have a team who knows how to do that stuff, right? I'm sophisticated enough that I'm already doing cloud. I'm already doing that stuff. And that's okay. Some other customers just prefer to, not manage infrastructure, and they're happier calling an API. But maybe they like the fact that they know the model, that is actually hosted behind the API. Maybe they feel more comfortable. Maybe it's less of a black box. And they also tend to be cheaper, because generally they tend to be smaller models. So if you have a hosted Llama, if you have a hosted Mistral, or hosted Quen, whatever, generally tends to be a little cheaper than your top of the line OpenAI or Anthropic model. But yeah, I think it's, again, there's no silver bullet for all those things. If you're happy working with a model that you can also run in-house, you can experiment in-house. Maybe you can even customize it in-house and then go and deploy it on a hosted API because you don't want to deal with pain and the costs of GPU hosting. Why not?
Right. Like the training of a model and the operation of a model are two very distinct things. And
yeah,
historically, it's been all about training because models were not good enough, at least for generative AI. Now that it's good enough, the focus, I think, is way more on operation, right, and reliability. So there's definitely been a shift. Do you see, of course, there is the term MLOps that's been around for a while, but do you think we are seeing new roles or teams emerging, because of this rush towards GenAI in operation?
Yeah, there are some specific skills for sure. And you could say, well, a model is just an endpoint, right? It's just an API. So, maybe it runs on a GPU, but at the end of the day, like I said, it's all about uptime and speed and monitoring and observability, etc. But an AI app is just more than a model. And I think that's where the specific skills come in. It's not just, hey, let's deploy the model container and make sure it runs. There will be other moving parts, right? There could be several models. If you want to go into agents, you will have several models and they will be chatting, etc. And, you will have other elements, like if you run a knowledge base, probably you're using retrieval augmented generation. So you're retrieving some good stuff from maybe a vector database or an equivalent system, and you're injecting it into the generation process. And maybe you have, guardrails models to try and save your users from, nasty model behavior and legal problems, etc. So it's way more than just, I have an OpenAI compatible endpoint and bam, let's hit it. You have a bunch of services, and of course you have an app somewhere, right? Probably you did all of that because you want to serve inference to an app, whatever it is. Could be conversational, or it could be, app to app, who knows? So keeping all that stuff on the road, it becomes a distributed system in itself, right? And keeping that stuff on the road, keeping it, fast and up and observable is a fair amount of work. So I think that's where the new skills are. What does it mean to build an AI stack that can serve at scale, 24/7, not just a model, but also, all the stuff around it. Some folks have, they're caching prompts. They're automatically rewriting user prompts to optimize them. They have prompt libraries. I mean, not all those things exist everywhere, but, some of them do. Those consultant slides and that you see, and they want you to believe that if you don't have those 23 different systems, you're not really doing AI. It's all BS, of course. It's consultants trying to make things complicated to charge you more. But some of those building blocks will be in your platform, and they make sense. You need people that understand the workflow end to end and can go and debug, fix them, and scale them. If that's my definition of MLOps, not just running the model.
Definitely an emerging practice, and as you said,
sure.
we are at the very beginning of it, and there is so much to learn. Exciting time we are living in.
Absolutely.
Julien, if people want to get in touch with you on the internet, where can they find you?
Where can they not find me? Yeah, well, I guess, LinkedIn, of course, happy to connect. And I'm trying to answer questions, in a reasonable time frame, but you have to bear with me. I have a YouTube channel, which has been quiet in the last few weeks because I've been traveling too much. But there's definitely more content coming, and RC is launching amazing new models in the next couple of weeks. So expect some content there. Just look for me on YouTube. I'm generally very easy to find. People don't complain they can't find me. They complain I'm not answering fast enough, but that's how it is. There's just too little time and too much to do. But I'm trying. I promise I'm trying.
Actually, you are one of my few guests on the podcast where you can find Julien online, but you can also find him offline. Julien is traveling like an amazing amount and at all the top
Yes.
conferences, right?
Yeah, I'm trying to be honest with you. I'm trying to slow down a little bit, but because I hate to say no, but if it's in, I'm based in Paris, right, outside Paris, but if it's in Europe, it's reasonably easy, and there's no, I can easily fly from Paris to anywhere, and it's generally under 2 hours, so it's no
Right.
big deal. But going to the US is just it takes days out of my schedule, and jet lag kills me every single
Yeah.
time. I've never gotten used to it, and trying to stay efficient and functional. And I have to slow down and stay home a little bit more. But you'll still see me out there for sure.
All right. Well, I'm actually looking forward to meeting you online, Julien. Thank
Yeah,
you for
sure.
coming on the podcast.
Thank you for having me. Thank you very much.